Here's another video once again, which is based on Fourier integrals, more problems. So now the first problem that we have, we're given, we have to find the integral from 0 to 2 of cosine of nx, n pi x divided by 2 and then dx. So integrating that, integral of cosine we know is a positive sign, n pi x divided by 2 and then divide by n pi over 2, which is the derivative of the inner function, because we're integrating that with respect to x. So that's integrated from 0 to 2. So we can we see that according to the fraction laws, that's gonna be 2 over n pi. And then we can swipe it, we can take it out as a common factor. We put sign of, now we substitute the higher limit there too, we get n pi and minus sign of 0 when we're substituting the lower limit. So you can see that we're gonna have 2 over n pi and that's going to be 0. We already know by now that sign of n pi will be 0 and that's gonna be 0. That's our final answer, because any number that we substitute here from 1 to 100, a negative number, anything, that's gonna give us a 0. So I have the second problem again. So the second problem, we have 0 to the integral evaluated from 0 to, and then that's n pi x and then divide by 2 and then dx. So that's going to be the integral of that should be negative cosine of n pi x. So you should be knowing integration by now, so that you can easily evaluate these problems. So that is evaluated from 0 to 2, and then we can take that once again as a common factor. That's gonna be negative 2 over n pi, and then we are left with the cosine. We substitute the lower limit, the higher limit, we're gonna get n pi minus cosine of 0, and then this is gonna be negative 2 over n pi into cosine of n pi minus 1, which is the cosine of 0. So when you substitute here, we're gonna get negative 2 over n pi into, when you substitute numbers there, when you will get negative 2 when you substitute all the odd numbers, and then you will get 0 when you substitute even numbers. So that's it. And then can just say maybe 4 when you multiply that to the inside, gonna get 4 over n pi, and then obviously here you're gonna get 0. This when n is equal to odd, and then when n is equal to even, and then that's what you have there. So that's our solution. So the next problem that we have problem number 3. We have 0, we have negative 3 to 0, and then we have sine of n pi and then x divided by 3 and then dx. So we're going to have what, negative cosine of what, n pi x over 3, which is the integral of sine divided by the derivative of the inner function over 3, and then evaluated from negative 3 to 0. And then what we're gonna do now is that we're gonna substitute the higher limit, which is 0. So we can take 3 over n pi, and then now let's take negative, you say cosine. Now when substitute 0, we're gonna get cosine of 0. When we substitute negative 3, you're gonna get cosine of n pi. So that is what we have there. After that, we can say now this is equal to negative 3 over n pi into 1 minus cosine of n pi. After that, we can say now we have negative 3 over n pi into so now that's negative 3 over n pi, and then we have 2 when we substitute odd numbers, we have 0 when we substitute even numbers. So that is our solution. We can now put it as final as negative 6 over n pi, and then we put here again 0, and then obviously that's gonna be odd when n is equal to odd numbers and when n is equal to even numbers. So that is our final solution. So the next problem, number 4, we have integral from 0 to pi over 2, and then we have cosine of nx, and then dx, and then we have plus integral from pi over 3 to pi, and then we have 2 cosine of nx, and then dx. So what do? We integrate. We're saying now integral of cosine will be sine of nx, and then divided by n. Then this is evaluated from 0 to pi over 2. We say plus now 2 as a constant. Integral of cosine will be a positive sine of nx divided by n, integral of the inner function. This is evaluated from pi over 2 to pi. So now we can actually substitute our limits. When we substitute pi over 2, we get sine n pi over 2, and then all over n, minus, when we substituting 0, we get sine of 0, which sine of 0 will just be 0. And then we say minus, we are going to substitute the lower limit. So the lower limit, for the second part, for this part now. So we're gonna substitute first the higher limit, which we know that when you substitute pi there, we're gonna get a sine of n pi, and we know that sine of n pi by now is 0, and then we say minus we substitute the lower limit, which is going to be sine of n pi over 2, and then divided by n. So we're gonna be left with sine of n pi over 2, and then divide by n, and then we have negative and negative. That should not be negative, so that means when we are substituting, this should actually be plus, because it was plus from the question, so that should be plus, and then that should be minus 2 sine of n pi over 2, and then divided by n, and then you can see that those are like terms. We'll get negative sine negative 1 minus 2 is negative 1 sine n pi over 2, and then we divided by n. So next we can say negative 1 over n, and then into sine of n pi over 2. So now this now will be negative 1 over n into, so write that better. So we get 1 when we substitute n is equal to 1, and we get 0 when we substitute n is 2, and we get negative 1 when we substitute n is equal to 3. When we substitute n is 4, we get 0, n is 5, we get 1, n is 6, we get 0, n is 7, we get 1, n is 8, we get 0, n is 9, we get 1, and then when n is 10, we get 0, and when n is 11, we get negative 1. So we can actually see now the trend that will be having 1 over n, and then into, and then we said we get 1 0, and then we get negative 1. So when n is equal to 1 5 9 etc., and then when n is equal to, when we get negative 1 is when we substitute n is 3, 7, and 11, etc. So here obviously when n is equal to an even number always, so that is our solution there. So the other problem, the last problem, we have 1 over pi, integral from pi to 2 pi, and then we have x, and then we have sine of nx, and then dx. We can use by parts here, say 1 over pi, now into, we're gonna get uv minus what? Minus integral of v du, and then that's going to be, let's let maybe our u to be equal to x, and then our du should be dx, and then we can let our dv to be sine of nx dx, so that our v would be negative cosine, when we integrate that, negative cosine of nx, and then divide by n. So what do we do now is that we're gonna have 1 over pi, substitute there our u and v, we get negative x cosine of nx divided by n. This comes from multiplying by u and v, so that's what we get. So we say now minus, and then that's going to be the integral of what? The integral of v, and then our v is actually negative cosine of nx, so taking the negative sign outside is gonna make a plus here, and then if we can take out 1 over n also, and we'll be left with cosine of nx and then dx to simplify. And then after that, what we're going to do is that we're gonna have 1 over n, and then that's into, so we have negative x cosine of nx divided by n plus 1 over n multiplied by integral of cosine of nx will be sine of nx, and then divided by n, and that's evaluated from pi to 2 pi. So from here we're going to get 1 over pi, and then we say into negative x cosine of nx, and then divided by n plus sine of nx, and then divided by n squared, and then that is evaluated from pi to 2 pi. So after that we're gonna get 1 over pi to simplify that. Now when we're substituting our limits, now we're going to have negative 2 pi upper limit in place of x cosine n 2 pi, and then divided by n, and then we say if we substitute pi, that's gonna be sine pi n, which is just going to be a 0, then minus, substituting the lower limit, we're going to get negative pi, and then cosine of pi n divided by n, and then plus we substitute lower limit, we're going to get 0 because we have sine there. So unless we had 1 over 2 pi, then it will not be 0. So after this, we actually say that now we're going to have this pi cancels. So if we multiply brackets, this pi, you cancel that pi there. So that means now we are left with negative 2 pi cosine of 2 pi n divided by n minus plus pi cosine of pi n, and then divided by n. So that's the equation that we have. We can now take out also the 1 over n, negative 1 over n, and then we'll be left with the 2 cosine of 2 pi n, and then minus cosine of pi n. So that's what we're left with. So substituting there, we get 1 over n into we're going to get 1, and then we're going to get 3. So we actually get 1 when n is equal to 2, 4, 6, etc. And then we get 3 when n is equal to 1, 3, and then 5, etc. That means now simplifying that, we get into negative 1 over n and negative 3 over n. Of course, when n is equal to odd numbers, when n is equal to even numbers, we get negative 1 over n. And then when n is equal to the odd numbers, we get negative 3 over n. So that is how it is done.